Today, we're going to pull back the curtain on a real game changer, the optical sorter. And that's not just some sales pitch, you know? It's a real deal reality for recyclers all over the place. It's this amazing high-tech answer to one of the oldest headaches in the business. How in the world do you separate tiny mixed-up materials with crazy speed and accuracy?
Okay, so to really get why these machines are so brilliant, we first have to wrap our heads around the massive problem they were designed to solve. Let's dive into what recyclers are up against every single day.
All right, picture this. You've got a pile of granulated copper wire. Now imagine you just dump in a bunch of tiny flakes of brass, little bits of plastic, some aluminum. What you get is what people in the industry call a bird's nest. It's exactly what it sounds like, this clumpy, tangled-up mess where everything sticks together. Trying to sort that by hand? Forget it. And as a mixed-up mess, it's pretty much worthless.
And this right here really lays out the bottom line. On one side, you've got this low-value headache, but on the other, a pure commodity that's going to fetch a great price. I mean, that transformation is pretty much the whole point of the recycling industry.
So that brings us back to the big question, right? How do you actually sort these tiny little metal fragments when you're dealing with over a ton of it an hour? You can't do it by hand. You need a machine that can basically see, think, and react faster than any human possibly could. And what's really interesting is that this tech isn't even new. It's actually got a pretty cool history in totally different industries. It's just been adapted more recently for the really tough challenges of modern recycling.
Yep, believe it or not, optical sorters actually started out in places you'd never guess. Think about the food industry. They were used to spot and kick out a single discolored grain of rice or a bad grape in a huge harvest. Then you've got mining, where they separate valuable ores from plain old rock. And that backstory is super important because it shows these machines were designed from day one for exactly this: high volume, super precise sorting of tiny little things.
Okay, so how does this thing actually work its magic? Let's get into the nitty-gritty. We're going to look inside the machine, and really, the secret sauce is all about how the material gets in front of the cameras. So you've got two main types. First, there's the chute sorter. It literally just drops stuff past the cameras. The problem? Well, a heavy piece of copper falls way faster than a light little flake of aluminum, right? That timing difference is a nightmare for the air jets trying to hit their target. But the conveyor belt design? That's the game changer. It launches every single particle at the exact same speed. That gives you a nice, predictable arc, which is absolutely critical for what comes next.
And this whole thing happens in, like, milliseconds. It's crazy fast. The material is spread out on the belt, launched at that perfect speed, and then bam! High-speed cameras scan it from the top and the bottom as it's flying through the air. An AI brain instantly identifies the bad stuff, and a perfectly timed puff of air zaps it out of the way into a reject bin. Meanwhile, all the good stuff just keeps falling straight down.
The eyes of this machine, the vision system, that's really the heart of it all. Having two cameras is a must-have. Why? Because you might have a piece of scrap that looks like pure copper from the top, but flip it over and it's got aluminum stuck to it. The dual cameras catch that. The system also uses colored lights in the background to make the target material really stand out, to make it pop for the cameras. And the AI is super smart and easy to train. You basically just show it pictures of the good stuff and the bad stuff, and it learns, giving you that incredible precision.
Okay, so the hardware is obviously impressive, but the real genius here, it's in the logic. It's not just what the machine does, it's the strategy behind it, how it thinks to get the absolute highest purity possible.
And the core strategy is so simple. It's brilliant. It's this: always eject the minority. Think about it. If your material is, say, 98% copper and only 2% is junk brass, you don't tell the machine to pick out all the good copper. No way. You tell it to just target and eject that tiny 2% of brass. That way, your main valuable product is never even touched by the air jets. The result? The cleanest possible end product you can get.
But wait, it gets even better. The really advanced systems don't just stop there. They can take that reject pile, the brass and the little bit of copper that got accidentally blown over with it, and they can run it through the sorter again. So now, from just one messy input stream, you can create 2, 3, or even more separate, clean, and valuable products. It's incredible.
All right, so we've talked about all this amazing tech, but what does it actually do in the real world? Let me tell you, the results are, well, they're a total game changer. Just look at this transformation. You start with that clumpy, low-value bird's nest we talked about, a complete mess. Then, after just one pass through the sorter, what do you have? Over 99% pure copper. It's so clean and uniform that it literally flows like sand. You've taken something that was basically trash and turned it into a premium commodity that's ready to sell.
And for a recycling business, this makes so much sense financially. The return on investment can be super fast. You're getting more valuable material out of your scrap, you're getting paid top dollar because it's so pure, and you're throwing away less. A lot of folks even use these machines as their final QC check, basically guaranteeing their customers will never reject a shipment.
What's also wild is how efficient they are. You'd think a machine that's firing hundreds of air jets every minute would need this giant, power-hungry air compressor, right? But nope. The nozzles are so precise and the whole system is designed so cleverly that today's machines are incredibly efficient. I love how one operator described it. He said it just sips air.
And the speed? Also impressive. We're talking about a standard machine processing a ton of material every single hour. And they're so reliable that a lot of places run them lights out, meaning they just keep working and making money all night long, even when no one's there.
So it's clear this technology is already shaking up the entire world of recycling. But it kind of leaves you with this one big question, doesn't it? As our gadgets get smaller and the materials inside get more and more complex, how are these sorters going to have to evolve? What will the smart sorters of the future need to see that we can't even imagine right now?